Welcome back to the deep dive. Today, we're really jumping in, taking the fast track into securing modern Java applications.
Yep.
We've basically torn apart this practical guide focusing on Spring Security 6. It's the latest heavyweight framework out there. We're specifically looking for the fastest, the most effective techniques you need to build secure apps right now.
That's right. The source material we used, it's a really fantastic collection of recipes for developers. And our mission here is to kind of distill the core architectural shifts in Spring Security 6. Because this framework, it provides really comprehensive security authentication, authorization, protection against, well, all the nasty web vulnerabilities like CSRF, Session Fixation, all built specifically for the modern Spring ecosystem.
Okay, so first things first, before we even think about code, what's the absolute baseline, the non-negotiables for this version?
The requirements are pretty clear-cut this time. Because version 6 is all about leveraging modern Java performance. You absolutely must be running on Java 17 or higher.
17, okay.
Yeah, Java 17 plus DIS paired with Spring Framework 6 and Spring Boot 3. Spring Security 6 is built for this modern stack, so trying to use older environments, it just won't work. It's not backward compatible in that way.
Got it. So baseline set. Now let's unpack this a bit. Why do Java developers, overwhelmingly choose Spring Security in the first place? And maybe more importantly, why is version 6 making everyone, sit up and pay attention right now?
It really boils down to the depth and the flexibility.
Yeah.
Spring Security isn't just like a simple login form tool. It's much more, think of it as a security fortress for your app. It delivers really sophisticated web security, right? Protecting against common threats, XSS, CSRF, clickjacking, the usual suspects. Gives you robust role-based access control, URL security, and even the ability to define incredibly fine-grained authorization using access control lists,
Right.
ACLs.
Object-level security.
Exactly. And the beauty, as you hinted, is that it handles all of that outside your main business logic. It works mainly through filters and annotations, which makes it far less intrusive than, say, older Java E security models.
Much cleaner integration, definitely.
It's very modular. But the jump to V6, it really signals a major architectural evolution. And it's driven by maybe 4 key areas. First, that high baseline requirement, we mentioned Java 17 plus Ski, that directly translates to better native performance.
Okay, performance boost. Makes sense.
Second, and this is a big one, it actively supports the industry shift toward zero trust security principles.
Zero trust. Okay, that term gets thrown around a lot.
Yeah.
What's that practically mean for a developer sitting down to configure Spring Security?
Practically, it means no implicit trust.
Yeah.
Ever. In older security models, maybe once you authenticated, you might sort of trust internal network traffic more.
Yeah, inside the firewall was safe?
Right. But under zero trust, every single request, it doesn't matter where it comes from, internal, external, whatever, it must be explicitly authenticated and authorized. And this thinking leads directly to the third big point, the new Authorization Manager API.
Okay, tell us about that. Is the Authorization Manager API the thing that actually enforces that zero trust idea you mentioned?
Precisely. Think of it as the centralized brain for managing all your access control rules. Instead of scattering access checks across different configurations or using older, maybe now deprecated patterns, this new API gives you a single unified place.
Ah, okay. One spot to define everything.
Exactly. It makes the configuration much cleaner, much easier to reason about, and it simplifies enforcing those granular checks after authentication for every single request. That's really how you operationalize zero trust within Spring Security.
Makes sense. And if we connect this to the broader identity landscape, it keeps up there too.
It absolutely does. The fourth driver is updated standards compliance, specifically really robust support for OAuth 2.1.
Okay, the latest standard. Good.
Yeah. And crucially for modern apps, whether you're building traditional web apps or reactive systems, it runs seamlessly on both.
Yeah.
So traditional synchronous stacks like Spring MVC and the asynchronous non-blocking reactive stacks like Spring Web Flux, it supports both equally well.
That's a really powerful mix, standardization, modernity, flexibility across stacks.
Okay.
So if you, the listener, are ready to start putting these techniques into practice, what does your development setup, your desk need to look like? What tools are essential?
Right. Since we're focused on these practical recipes, you need the right toolkit. We can probably skip the full install tutorial details.
Yeah, let's assume people can install software.
Okay. The absolute must-have is the Java SE Development Kit version 17 or newer. The source we looked at used 23, but 17 is the minimum. And yes, you really need a professional IDE that handles Spring Boot well. IntelliJ IDEA Ultimate was used in the source, and frankly, its Spring support is generally considered top-notch.
Better than, say, Eclipse with STS.
Often, yes, especially out of the box. Eclipse with the Spring Tools 4 plugin is free and capable, of course, but IntelliJ often feels a bit smoother for Spring development. Also, you'll need Maven version 3.9.9 was used, and potentially an external Tomcat server, like V11, depending on the specific recipe or deployment.
And don't forget setting Java home properly, right? That catches people sometimes.
Oh, absolutely crucial detail. Setting the Java home system variable and making sure you append the bin directory to your system's path variable. Standard Java setup stuff, but easy to miss.
Okay, speaking of tools, Maven. The source material uses Maven, but this inevitably brings up the build tool debate for many teams. Maven versus Gradle. Can you quickly clarify the deciding factors there? When would you pick one over the other?
Ah, yes, the perennial debate. It usually comes down to project scale and how much flexibility you need. Maven is really the king of standardization. People choose it for its simplicity, its consistency. It has very robust dependency management through that convention over configuration approach.
Right, the XML structure is very defined.
Exactly. So for smaller projects or foundational ones like maybe these security recipe examples, Maven offers reliability and, frankly, ease of getting started because it's so common.
Okay, standard choice. And then what pulls developers towards Gradle?
Gradle really shines when you need flexibility and performance, especially at scale. Many developers prefer its build script language. You can use Groovy or the Kotlin DSL over Maven's XML. It allows for much more custom logic.
More programmatic control.
Precisely. And perhaps most importantly for really large code bases, Gradle's incremental builds and its aggressive caching mechanisms often mean significantly faster build times, particularly if you're dealing with complex, multi-module, corporate-style projects.
Okay, so to simplify, standardization and maybe simpler projects, lean Maven. Flexibility, customization, and high performance, especially on big projects, lean Gradle.
That's a good way to frame the trade-offs, yeah.
Great. Let's move from the build tools now to the application front end. We've got our authentication sorted, our authorization rules are maybe defined using that new authorization manager API in the back end. How do these security recipes help us control what the user actually sees, specifically in the view layer, using tools like, say, Timeleaf?
Right. View security is super important because authorization isn't just about blocking a URL request entirely. Sometimes you want the user on the page, but you want to hide or show specific elements based on their permissions.
Yeah, better user experience that way.
Exactly. So Spring Security integrates with view technologies to allow for what's called declarative security, right in your HTML templates.
Okay, so how does that work with Timeleaf? It's so common in the Spring world.
With Timeleaf, you integrate it using an extra library, Timeleaf Extra Spring Security 6, Symbol Dependency Add. This library gives you special attributes you can add directly to your HTML tags.
Ah, okay, like little security markers in the HTML itself.
Exactly. The key nuggets here, the things you'll use most often, are expressions like sec.authorize is authenticated. That just checks if anyone is logged in. Or you can get more specific, like sec.authorize has role admin, to check if the user has that particular admin role.
And you can pull user data too.
Yep. You can display things like the logged in user's name using sec.authentication name. It pulls directly from the security context.
But that seems really powerful. A very tight link between the backend security rules and what gets rendered on the page. What about developers who might still be using maybe older view tech like JSPs? Is there support there too?
Oh yeah, Spring Security hasn't abandoned JSPs. It provides dedicated JSP tags through another library, Spring Security Tag Libs. Functionally, it offers the same kind of control, just implemented with, XML style tags instead of Timeleaf attributes.
Gotcha. Same idea, different syntax.
Right. For example, you'd use sec.authentication property name to display the username. And for controlling visibility, you use a tag like sec.authorize access has role, add DMIN. Inside that access attribute, you use Spring Expression Language, SPEL, to define the condition.
SPL again. Very flexible. Okay, we should also quickly touch on customizing the login process itself, moving away from that default page Spring Security generates. That's almost always a requirement in real apps, right?
Absolutely. The default generated page is functional for getting started, but production apps need branding, custom styling. The recipe for this shows that when you configure a custom login form in your security configuration, being typically using .login page login pointing to your custom controller mapping, Spring Security is smart enough to automatically disable its own internal default login page generating filter.
Okay, so it steps aside once you provide your own.
Exactly. But there's a key configuration trap here that catches people. You have to remember that your custom login form must use the HTTP POST method by default. And, crucially, it must submit the username and password fields with the specific names, username, and password.
Ah, convention over configuration strikes again.
It does. Unless you explicitly go in and reconfigure those expected parameter names, which you can do. But the default expects username and password via POST.
Good tip. Okay, now let's get into something more robust. Persistent users. In-memory users are fine for demos, maybe basic tests.
But totally unrealistic for production.
Yeah. So real-world apps need a database. How does Spring Security 6 handle database authentication? Let's say using a common setup like the embedded H2 database and standard JDBC.
Okay, this moves us into a more modular and obviously persistent setup. Spring Security manages authentication methods through its authentication provider interface. It's very pluggable. For JDBC-based authentication, the central component you work with is the JDBC User Details Manager. This class actually extends another core class called JDBCD-Impl, and it handles the full lifecycle loading user details, checking passwords, potentially even managing users, all through standard JDBC calls to a database.
Okay, so JDBC User Details Manager is the key player. Setting this up then means connecting the security configuration to a data source, right? What are the minimal steps, say, for H2?
Right. First step, dependencies. You need to add Spring Boot Starter Data JDBC and the H2 database driver, comp.h2database.h2, to your Maven or Gradle build file.
Standard Spring data setup.
Pretty much. Then for easy development and testing, you'll configure your application.properties or application.eml file. You'll typically want to enable the H2 web console for debugging using spring.h2.console.enabled. And you need to specify the database URL. For an in-memory H2 database, that's often something like jdbc.h2.mm.securitydb. The mem part signifies it's in-memory.
Got it. So connect Spring Data JDBC, enable the console, point to an in-memory H2 instance. What about the database schema? What tables does Spring Security expect to find in that H2 database?
This is where understanding the defaults is really helpful. Out of the box, that JDBC detail impl class we mentioned expects and can even create for you two specific tables. There's a users table. This holds the username, the password, which must be encoded using a configured password encoder.
Ah, important detail. not plain text.
Absolutely not plain text. So username, encoded password, and an enabled status flag for the user. Then there's a second table, typically called authorities. This table maps the username to their granted roles or authorities, like username admin has authority, role admin.
Okay, users and authorities. Pretty standard schema. Does it create these automatically?
It can. JDBC data impl actually points to default DDL scripts. JDBC data impl default assertion mad location. If you're using something like Spring Boot with schema generation enabled, it might run these scripts on startup against your configured data source, like the H2 in-memory DB.
Handy. Now, let's talk about a crucial configuration detail, a real nuance that trips up so many developers when they first try using H2 with Spring Security enabled. Accessing that H2 console itself often fails. Why?
Right. This is where that zero trust concept, or at least the default secure configuration, kind of collides with developer convenience. By default, Spring Security enables CSRF protection globally, which is good. It prevents cross-site request forgery attacks.
Essential protection.
Totally. But the H2 console often runs in a frame and might involve requests that look suspicious to the CSRF filter. So rule number one, you must explicitly tell Spring Security to ignore CSRF protection, but only for the H2 console's path, which is usually H2 console.
Okay, create an exception for that specific path.
Exactly. But there's a second, often more obscure problem. You also usually need to disable certain HTTP security headers, specifically the ones related to frame options.
Frame options, like X-frame options.
Precisely. X-frame options, often set to deny or SAM origin by Spring Security's defaults to prevent clickjacking attacks. The problem is the H2 console needs to run inside an HTML frame. So if that header is set to deny framing, the browser simply won't load the console page. It'll just be blank or show an error.
So you need to configure the security filter chain bean to specifically allow framing, again, just for the H2 console path, or maybe disable that header entirely if you're only in development.
Correct. You modify the header's configuration, usually setting frame options.disable, or configuring it appropriately within your security filter chain bean. It's a common hurdle.
That is a perfect example of a deep dive nugget right there, connecting a high-level security feature clickjacking protection via frame options directly to a practical why isn't my tool working configuration tweak needed for the H2 console.
Yeah, those little details matter. Once you have the dependencies, the properties set, the schema in place, and those security filter chain exceptions configured correctly, the result is that maybe upon application startup, if you're using schema generation and data initialization scripts, users like user pass and admin pass can be created and stored right there in the H2 in-memory tables, ready for robust database-backed authentication using JDBC Users Details Manager.
Fantastic. Modular and secure persistence. Okay, this has been a really insightful deep dive. We've covered a huge amount of ground. We established that Spring Security 6 is really the go-to framework for modern, high-performance Java 17 plus applications. It's driven by significant architectural improvements like that new Authorization Manager API and a clear alignment with zero trust principles. We condensed the essential toolchain Java 17 plus, Maven, or Gradle, depending on your needs, a good IDE. We reviewed how to control what users see in the view layer using declarative security in both timeleaf and JSP tags, plus the gotchas around custom logging forms. And finally, we clarified the essential setup and those tricky configuration nuances for enabling robust database authentication using H2 in JDBC.
And I think what this really demonstrates is that Spring Security, especially version 6, provides this incredibly powerful yet flexible environment. It's ready for serious, secure deployments. And it's worth maybe reiterating, because of its underlying modularity, that authentication provider interface, everything we talked about today, from JDBC auth to the zero trust rules applied by Authorization Manager, it can all be quite readily reconfigured to support pretty much any modern identity provider or protocol you need. LEIP, JWT, SAML, external OS2 identity providers. The framework is built to handle them.
That flexibility is key, which brings us perfectly to our final provocative thought for you, the listener, to mull over. Our entire conversation today really centered on securing a, let's call it traditional web application, one that probably relies on server-side sessions and a familiar login form.
Yeah, the stateful model.
Exactly. But given the massive industry shift towards API-first architectures, microservices, applications that communicate primarily using stateless tokens like JSON Web Tokens, JWTs, how might the concepts we discussed, particularly those granular authorization checks implemented via the new Authorization Manager API, need to be restructured or reevaluated? Think about securing those stateless token-based services versus protecting pages behind a typical browser login. How does the enforcement change? That's your challenge to explore.
A very relevant question for modern development. Until next time, keep diving deep.